Welcome dear students. In this lecture we are going to talk about the difference between the aromatic, anti-aromatic and non-aromatic organic compounds. This topic is very simple and we are going to make it even simpler in this lecture. Whenever an organic compound is written in front of you, first of all you will study that organic compound with respect to its three characteristic features. Whether it is cyclic or not, whether its structure is planar or non-planar, and whether it has conjugation or it is non-conjugated. If there is an organic compound which has cyclic structure, mean the closed ring structure, if it has planar geometry, mean all the carbons in the organic compound they are sp2 hybridized, and if it has conjugation, mean the alternate pi bonds or the delocalized pi electrons or the delocalized charge. Then, my dear students, any organic compound having these three features that may be aromatic or that may be anti-aromatic. Now, the aromaticity will be decided by the pi electrons. If an organic compound is cyclic, planar, conjugated, and the pi electrons, according to this formula, 4n plus 2, where n is a simple integer starting from 0 to any number, and if the pi electrons are 2, 6, 10 or 14, then that organic compound will be considered as the aromatic compound. So aromatic compounds are those organic compounds which have cyclic structure, planar geometry, they have conjugation or cyclic resonance, and the number of pi electrons are either 2, 6, 10 or 14. These compounds are the aromatic compounds, and this aromaticity is defined by the Huckle rule. This formula to calculate the pi electron, it was presented by the Huckle, so this is called as the Huckle's rule. And my dear students, if there is an organic compound which is cyclic, planar and conjugated, but the pi electrons, they are not 2, 6, 10 or 14, rather they are the multiple of 4. Here n can be 1, 2, 3 or any number, and the pi electrons are the multiple of 4. They are either 4, 8, 12, 16. Then my dear students, that organic compound will be considered as the anti-aromatic organic compound. You are just required to memorize the first number, and after that you will keep on adding 4. Just like here, this is 2, you will add 4, it will become 6, then you will add 4, it will become 10, then you will add 4, it will become 14, and so on. Similarly, here the first number is 4, adding 4 it will become 8, then adding 4 it will become 12, then adding 4 it will become 16. So just memorize the first number, that is 2 in case of aromatic and 4 in case of anti-aromatic compounds, and then you will keep on adding the 4 digit and you will get the pi electrons. Now my dear students, if an organic compound has cyclic, planar and conjugated geometry, then that can be aromatic or anti-aromatic. But if there is an organic compound which lacks any of these three features, that may be non-cyclic, that may be non-planar or that may be non-conjugated. If any of these three features is not seen in an organic compound, then that organic compound is called as the non-aromatic organic compound. There is no need to calculate the pi electrons in case of the non-aromatic organic compounds. So let us revise aromatic and non-aromatic and anti-aromatic. They have three common features. They are cyclic, planar and conjugated. The difference is just in the number of pi electrons. If they are 2, 6, 10, 14, then that is aromatic, and if they are the multiple of 4, then that is anti-aromatic. And if an organic compound lacks any one of these three features, then that will be considered as the non-aromatic organic compound. Now let us discuss some practice problems. But before discussing the practice problems, let me tell you one very important point, that in an organic compound where negative charge is written, that will be equivalent to the 2 pi electrons. The lone pair which gets involved in the resonance, that will also be considered as equal to the 2 pi electrons, and the pi bond, that will be obviously made up of the 2 pi electrons. So negative charge is equivalent to 2 pi electrons, then lone pair that gets involved in the resonance, that will be equivalent to the 2 pi electrons, and pi bond, no doubt, that is equivalent to the 2 pi electrons. So let us see the first structure, this one. My dear students, in this structure, these two carbons that are doubly bonded, they are sp2 hybridized. But this carbon shown in the red, that is having all single bonds, so that will be sp3 hybridized. Now this compound is cyclic. Yes, this one is cyclic. But is it planar? As it is having one sp3 hybridized carbon, so it will be having non-coplanar geometry. You are well aware of the fact that the sp3 hybridized carbons, they give the non-coplanar tetrahedral geometry to the molecule. So it means it is cyclic, but it is not planar. And as I have already mentioned, that if any of these three characteristics is not observed in an organic compound, that can never be aromatic or anti-aromatic. It is confirmed that this one is non-aromatic. And even the conjugation is absent in this compound. Now this one is the next one. It is cyclic, and as all the carbons, they are sp2 hybridized. You know that the carbocation carbon, that is also sp2 hybridized. So all carbons are sp2 hybridized. It will be planar, and there will be conjugation between this positive charge and these pi electrons, and this positive charge will keep on rotating on the different positions in this structure. Sometimes the positive charge will be here on this carbon, sometimes it will be there at this carbon, and sometimes it will be here at this carbon. And similarly, the pi bond can also change its location toward the molecule. So it means the conjugation is present. It is cyclic, it is planar, it is conjugated. Now we will calculate the number of pi electrons. My dear students, there is only one pi bond. There is no negative charge. There are no lone pair of electron. So one pi bond is equivalent to the two pi electrons. So it has two pi electrons, and this, according to the Huckle's rule, that should be now aromatic compound. So this one is aromatic organic compound. Similarly, benzene, you are well aware of the fact that it is cyclic, planar, and it has alternate pi bonds, so it has conjugation. And the number of pi electrons, because of the three pi bonds, that will be 6. And you can see the number 6 here. So benzene is also aromatic. Similarly, this one is naphthalene. It is cyclic, planar, and conjugated. And as there are 5 pi mods, so it will be having 10 pi electrons. And again, this 10 number is seen in this Huckle's formula. So that will also be considered as aromatic. Similarly, my dear students, this is anthracene. It is cyclic, planar, and conjugation is there because of the alternate pi bonds, and the number of pi electrons due to the 7 pi bonds, that will be 14. And again, this 14 is in the Huckle's formula, so that will be aromatic. Now, my dear students, what's about this one? This one is the cyclohexene, and you can see that these two carbons having double bond, they are sp2 hybridized, but all the carbons which are shown with these red dots, they are sp3 hybridized. So this structure is cyclic, but it is not planar, so it will be an example of non-aromatic molecule. Similarly, this one is another structure in which you can see that this is cyclic, but it is again not planar because these carbons will be sp3 hybridized, so it will also be an example of non-aromatic. When any of these three features is absent in a molecule, that is confirmed that it is non-aromatic. There is no need to go further for the pi electrons. Now, similarly, in this one is the pyridine. In pyridine, there are 3 pi bonds, so there will be 6 pi electrons. As this lone pair of the electron on nitrogen is outside the ring, so it will not get involved in the resonance with the pi bonds. So you will consider pi electrons equal to 6. And my dear students, here again, it is cyclic, planar, and conjugated with 6 pi electrons, so that will also be aromatic in nature. Similarly, this one is furan. In this furan, there are 2 pi bonds with 4 pi electrons, and there are 2 lone pairs on the oxygen. The one lone pair is outside the ring. It will not get involved in the resonance with the pi electrons. But this lone pair, as it is present in the ring, so it will keep on moving in the furan molecule, and the location of the pi bonds, that will also keep on changing. So that's why it is having conjugation. There are 2 alternate pi bonds. It is cyclic, it is planar, and the number of pi electrons here, that are again 6, 4 electrons of the 2 pi bonds and 1 lone pair. So pi electrons are 6. It is again aromatic in nature. This one is pyrrole. In this pyrrole, again, the pi electrons are equal to, there are 4 pi electrons in form of 2 pi bonds. And this lone pair again gets involved in the resonance, and it is again changing its location on the ring. So again, the pi electrons will be 6. These three all they are aromatic. Similarly, this one is thiophene. My dear students, again it has 6 pi electrons, 4 in the form of 2 pi bonds and 1 in the lone pair. So it will be having 6 pi electrons. As all these three, they are satisfying all conditions of the aromaticity. So we will consider all of them as the aromatic compounds. But there is difference between these three aromatic compounds and these four aromatic compounds. These three, they are having only carbon atoms in their ring, so they are called as the homocyclic aromatic compounds. But these four, they are having some atom other than carbon in their ring, and that atom is called as the heteroatom, just like the nitrogen, oxygen, and sulfur. These are the heteroatoms. And because they are having some heteroatom in their structure, so they will be considered as the heterocyclic aromatic compounds. The last one is cyclobutadiene. My dear students, you can see that it is cyclic. It is also planar because all carbons are sp2 hybridized. And again, my dear students, there is conjugation seen. It means the first three conditions are fulfilled. It is cyclic, planar, as well as alternate pi bonds are there. So it is conjugated as well. Now, it can be aromatic or anti-aromatic. Now, this cannot be non-aromatic. The pi electrons that are 4 because of the presence of just 2 pi bonds, and the 4 pi electron that do not fall in the Huckle's formula, they will be here in this case. So it will be considered as an anti-aromatic molecule. So in this way, you can distinguish between anti-aromatic, aromatic, and non-aromatic molecules. Just first of all, see these three features. If these three features are there in a molecule, then calculate the pi electrons. If they fall in the Huckle's formula, that will be aromatic. If they do not fall in the Huckle formula, rather they are the multiple of the fours, then that will be the anti-aromatic molecule. Similarly, if any of these three features is not present in any molecule, that is considered as the non-aromatic one. So I hope so that the next time whenever you will see any molecule, you can decide by yourself whether it will be aromatic, non-aromatic, or anti-aromatic by this simple discussion that we have discussed today. This was all about the lecture. If there is any problem, you can ask in the comment section. I will answer that. Till then, take care.